Okay, so I really like this chronometer app. And what I'm thinking is for next semester, so it's not you guys, so you can give me your honest truth, okay? So if you don't like the idea, say it. I think I want everyone to follow their diet for the whole semester on chronometer. And at the end of each week, they just have, there's a summary, like a week summary in chronometer. You just have to do a screenshot of it and send it in at the end of the week. What do you think?
Would that be like a track your meal every day,
every meal, everything you put in your body.
I'm gonna put like a lot. I personally think that's way too much.
Is it?
Yeah. With like everybody else's classes and other homework
Yeah,
and
it's
stuff,
probably too much.
that's a lot to do.
But you got your phone right with you while you're doing your food. You can just do your food.
My diet is like a month.
Well, that's the whole point. That's the whole point of this.
Well, because it's been easy.
I just like
To
some.
be effective, doing it for the whole semester is going to be way better than doing it for a week. Because then I'll actually give it time to be a habit.
So should I just, maybe not the whole semester, but maybe not a week either, maybe a little longer than a week?
Yeah, like a unit for like a single week. The last half. Yeah.
So how many people say that 2 weeks is okay? All right, what about a month? So a month is still good. That's the most that I think I'd actually do, a month. All right. And the point being is that all of your minerals and all of your vitamins and all your different, the carbohydrates and all that, all those micronutrients are listed on there. So then you'll know very well what you need to supplement with. You'll know if you need to take a multivitamin. You'll need to know if you need to do omega-3s. You'll need to know what you need to supplement with your diet, and you'll get patterns. So I think it's just a super, super healthy way to analyze things. And it'll save you a lot of money, so you don't have really expensive urine that doesn't really help you. You'll have nutrients that get into your body that'll be helpful, and you'll be able to balance yourself and stay healthy through the semester. Because if you don't have good nutrients through the semester, you get sick, and I don't want you guys sick. Okay, so today I got off on this tangent at home, of course, and it's about, I've talked to you guys about diabetes and fat. Okay, well, it's not just good enough for me to say that. I need to back up what I'm saying. So there's a couple things I want to say here. Diabetes and sugar, everybody knows that, right? Everybody's heard of that, and that's been preached, and everyone, that's known. But what you don't hear a lot about is diabetes and fat. So I'm not going to say that diabetes and sugar is wrong. I want to present this other point to you so you can just wrap your mind around the other side of things, okay? So I'm going to show a couple videos. One just explains the physiology of how this concept works, and the other one is actually Dr. Greger, who has gone through multiple journals, nutritional journals, to kind of find out if this is factual or this is driven by Food Incorporated. Okay? So I'm going to start with that. So there is some concepts on here that may be new to you. It's okay, hang with it, because when we do the lecture today, they will be covered in lecture. Okay, so I was contemplating doing it at the end, do it at the beginning, and I decided to just try the beginning. Why is that making so much noise? Holy moly.
Did you want me to do the Devo stuff?
Oh geez, of course I did. I'm all excited and jumping into it. Yes, Devo, please. And I need you to stand in this area right here.
Okay.
So you're on video.
Oh, okay.
Yeah.
Okay. So this verse is the one that I wanted to share, and it says, "From the ends of the earth I will call to you, and my heart is faint. Lead me to the rock that is higher than I." Psalm 61:2. And I liked that because last week, I know I was feeling this, and I know a lot of my nursing student friends were feeling it, but starting back was really, really overwhelming, and it just felt like a lot, and it was kind of getting really hard. And so that verse was kind of nice because it just helped remind me that when you're climbing to the top of a mountain, it can be really overwhelming and tough, but if you just picture that God is there with you and He's helping you get to the top, then it's a little bit more doable. It just is a reminder that He's there and He's helping you and He's not going to let you fail. So I guess I just encourage you all to think about whatever is making you feel really worn down or making you struggle, and think think back to that verse, so Psalm 61 too, and it'll just be a nice reminder to help you through whatever you're struggling with.
Can you read that verse again?
Yeah. From the ends of the earth I will call to you when my heart is faint. Lead me to the rock that is higher than I. Psalm 61 too.
Thank you. Thank you very much. Did a good job. So giving devos is hard and it's vulnerable, so appreciate it. And I hope more of you would volunteer to do a devo. If you do a devo though, can you just turn in a piece of paper saying, this is the day, did this devo, this topic? That'll just remind me because that'll get in there and I'll remember to put it in the grade book. Okay. So I had this story told me once that this is what a lot of people do. I think this might be a Zen Buddhist teaching. Okay, so hang on to this one. So a lot of people start at the bottom of the mountain. Okay, and what they'll do is they'll circle around the mountain and they realize, yeah, it's time to climb. I gotta start moving forward. So they start climbing the mountain, and it gets really hard, and they start struggling, and it's like, oh, can't do this. So they'll think, man, you remember when I walked around the mountain, there was one spot that was easier. So they drop down, they move to that other spot they thought was easier, and they start climbing that part of the mountain. They climb, and it starts to get hard. And then there's a ledge they can't reach, and they go, this is too hard. So they drop down to the bottom of the mountain again, and then they look for an easier spot. And they go up, they find, this is great, I'm doing well, and all of a sudden they run into a hard spot, they can't get up, and then they'll drop down again, and they'll do this, and they'll circle the mountain, going up partially up the mountain, all of their life. So, when you're climbing up the mountain, this kind of fits into your story, because when things get tough, you gotta dig in, and you gotta just push through, and you gotta climb, and just give it your best shot. Because that other spot on the mountain, guess what, has the same rough spots too. It never gets easy. You're gonna run into these really hard spots, dig in, you push through, you ask God for assistance through the whole thing, and you'll make it. So, all right, let's say a prayer and get started. Our Father in heaven, we bow our head and we give thanks for this day. We give thanks for amazing Devo and just the opportunity just to focus on you this morning and just bring your spirit into this room. And just please bless each one of us with whatever we might need to help climb that mountain, especially when it gets tough. Help us just to remember to turn to you, ask for your guidance and assistance. Again, we're thankful for you. We're thankful for the relationship we have with you. We're thankful that you validated us as people and you put us on this earth, and we're so thankful for that. And we're most thankful for our Lord and Savior Jesus Christ, the atoning sacrifice he made for us. Thankful for his birth, his resurrection, his teachings. We say this in the life of Jesus Christ. Amen. Okay, so now we'll get to the videos. If I can find my cursor. This is crazy. I got no cursor. Okay, there it is. Okay, this is a video Dr. Barnard. He's a physician, he's an MD, and he has a strong opinion about fat and diabetes. So I thought we should cover this. This would be a good intro.
Back in 1980, about 100 million people in the world had diabetes, and by 2014, that number was over 400 million, and it's headed up toward 700 million or even higher. The answer is to take a look at what's going on inside the cells of the body. This is a muscle cell, and insulin, which you have naturally in your blood, attaches to the surface of the cell, just like a key attaching into a lock. That then signals little channels to bring glucose out of the blood into the cell. And there it goes. The problem is you also have beef fat, chicken fat, pork fat, fryer grease building up inside the cell. And just like chewing gum in a lock means the key won't work, that fat stops the insulin from being able to work properly. The answer, get the animal products out of your diet. No meat, no dairy, no eggs, and keep your hormones really low. That'll go a long way for preventing this disease.
So that's insulin sensitivity, and that's insulin resistance. So we talked about the insulin attaching to the membrane of the cell, and then what that does is that it communicates to the GLUT4 UT4 receptors, those channels go to the membrane then, and they draw in that insulin. Okay? And that's, well, not draw in the insulin, sorry, they draw in the glucose. That provides the cell with energy. So what he's saying is that those fats actually they block the hormone of insulin from sending signals to allow those GLUT4 receptors to work. Okay? Then also there's another physiological process that happens, and I think this next video will get to that too, so we'll cover that. So this next video is from Dr. Greger, and again, what I like about him is he just does, his only job is to read through nutritional journals and other journals that have to do with nutrition. And then what he does is he looks at who was the financial contributor and how is the study set up and does it have good validity and reliability. And then he pulls out the good studies, which in his opinion are the good studies, and then he comments on them. He does make money doing this, but he doesn't make money on his website. So his website's all free, just provides information, and he does make money just doing seminars on what he finds in the journals. So here you go. Here's Dr. Greger. I think have we shown a video of Dr. Greger before, or have I? No, this is new? Okay. He's pretty kooky, but he's pretty smart too. He's one of those kooky smart guys. So here we go.
Caused by insulin resistance.
Let me start again. So this is his website that's just free. He makes no money off of it.
Both prediabetes and type 2 diabetes is caused by insulin resistance. It is now accepted to be closely associated with the accumulation of fat within our muscle cells. This fat toxicity inside our muscles is a major factor in the cause of insulin resistance in type 2 diabetes, as it interferes with the action of insulin. I've explored how fat makes our muscles insulin resistant, how that fat can come from the fat we eat or the fat we wear, and how all fats are not the same. It's the type of fat found predominantly in animal fats relative to plant fats that appears to be especially deleterious with respect to fat-induced insulin insensitivity. But this insulin resistance in our muscles starts years before diabetes is diagnosed. This is a graph of fasting blood sugars in the 13 years prior to the onset of diabetes. Insulin resistance starts over a decade before diabetes is actually diagnosed, as blood sugar levels slowly start creeping up. And then, all of a sudden, the pancreas conks out and blood sugars skyrocket. What could underlie this relatively rapid failure of insulin secretion? At first, the pancreas pumps out more and more insulin, trying to overcome the fat-induced insulin resistance in our muscles, and high insulin levels can lead to the accumulation of fat in our liver, called fatty liver disease. Before diagnosis of type 2 diabetes, there's a long, silent scream from the liver. As fat builds up in our liver, it becomes resistant to insulin too. Normally, the liver is constantly producing blood sugar to keep our brain alive between meals. As soon as we eat breakfast, though, the insulin released to deal with the meal normally turns off liver glucose production, which makes sense as we don't need it anymore. But filled with fat, the liver becomes insulin resistant like our muscles, and so doesn't respond to the breakfast signal, and so keeps pumping out blood sugar all day long on top of whatever we eat. So the pancreas pumps out even more insulin to deal with the high sugars, and our liver gets fatter and fatter. That's one of the two twin vicious cycles of diabetes. Fatty muscles, in the context of too many calories, leads to a fatty liver, which leads to an even fattier liver. This is all still before we have diabetes, but then the next vicious cycle starts. A fatty liver can be deadly, so the liver starts trying to offload the fat by dumping it back into the bloodstream in the form of something called VLDL, and that starts building up in the cells of the pancreas that produce insulin in the first place. So now we know how diabetes develops. Fatty muscles leads to a fatty liver, which leads to a fatty pancreas. It's now clear that type 2 diabetes is a condition of excess fat inside our organs. The only thing that was keeping us from diabetes, from unchecked skyrocketing blood sugars, is that pancreas, was working overtime, pumping out extra insulin to overcome insulin resistance. But as the so-called islet or beta cells in the pancreas are killed off by the fat buildup, insulin production starts to fail. And we're left with the worst of both worlds, insulin resistance combined with a failing pancreas. Unable to then overcome the resistance, blood sugar levels go up, and we have type 2 diabetes. This has implications for cancer as well. Obesity leads to insulin resistance, and our blood sugars start to go up. So our pancreas starts pumping out more insulin to try to force more sugar into our muscles, and eventually the fat spills over into the pancreas as well, killing off the insulin-producing cells, and we've got diabetes. In which case, we may have to start injecting insulin at high levels to overcome the insulin resistance, and these high insulin levels promote cancer. It's one of the reasons we think obese women get more breast cancer. It all traces back to fat getting into our muscle cells, starting insulin resistance, fat from our stomach, or fat going into our stomach. So now it should make sense why the American Diabetes Association also recommends reduced intake of dietary fat as a strategy for reducing the risk of developing diabetes.
So what do you think? Is that new? I think from a logical perspective, it makes sense to me. But that's just one side of the story, though. I mean, the other side still is that, the increase in sugar intake is also going to create more glucose in the bloodstream, which will then create more insulin production, which can create a whole cascade of effects too. All that increased glucose will be stored then as fat, which will then increase fat in the muscle cells. So we've got two: increased fat from what we eat, and also increased sugar intake. Both are contributors to diabetes. But leaning a little bit more towards fat intake right now, that's what the science seems to be pointing towards. Just want to let you guys kind of digest that. Dad joke, yep. So, all right, so let's go down to, so today we are going to talk about fats. So some of the things that were mentioned in the video, we will go over right now. Okay, so fat is supposed to provide energy through the oxidative system. So right now as you're sitting there, 40% of your energy is being used from fat, or fat is producing energy, 40% of it, okay? In order for fat to use energy, it has to have oxygen. So we talked about that before. When we're exercising and our oxygen demands go way up, but our oxygen intake can't go up to match it, then we don't have enough oxygen for us to utilize fat for energy. So then we burn mostly carbon dioxide. And then, not carbon dioxide, we burn carbohydrates. When we burn carbohydrates, we only have so much of reserve, and then once we burn up our reserve, we hit the wall. So this whole oxygen is super important for fat and energy. So fats also provide essential fatty acids. So we have non-essential and we have essential. Does anybody know the difference between essential and non-essential?
Essential.
Exactly. So, do we need fat in order to sustain life? Do we have to take fat in to sustain ourselves? Okay. Yep, I will agree with that. When you hear Dr. Esselstyn, when he lectures, which he is a cardiologist out of the Cleveland Clinic, and he's and same with Dr. Campbell, they'll say zero fat in your diet, absolutely zero fat. These are just for people that have cardiac conditions, though, because they need to do the reversal. So I think when you eliminate all fat from your diet, I think what happens is you can't do that, because all foods will contain, well, not all foods, but some foods will contain fat, especially your nuts and your nuts and seeds, which contain the omega-3s, which you really need, which we'll get to. Also, vitamins transport fat. Fat transports fat-soluble vitamins. We'll get to that in just a second. So, 1 gram of fat equals 9 calories. 1 gram of carbohydrate equals how many calories? And does anybody know what 1 gram of protein, how many calories that is?
Four.
4. Yep. So fat contains the most calories, has the most energy. So 1 pound of fat is 3,500 calories. So if you want to coach someone on how to lose weight, what do you tell them to do? They're going to have to do what to their diet? Cut the fats, also decrease calories. So if you want to lose 1 pound of fat, that equals 3,500 calories. So if you want to lose that in a week, how many calories per day do you have to get rid of per day?
Lose a pound in a week?
To lose a pound in a week, how many calories do you have to cut per day? How much? 500. That's it. So when you coach them, the realistic goal is 1 to 2 pounds a week for decreasing body composition, which you would hope that is your body fat composition. So by doing that, you coach them to decrease their calorie intake by 500. So if you do a chronometer, you can definitely see that and you can track that. So, but yeah, that's what all they have to do. So 500 calories. I mean, if you think about it, it's like 2 Snickers bars. It's like, you know, maybe 2 Cokes. That maybe it's not that hard to do. Eliminate 500. But anyway. Okay, so now we've got all these people telling us what we should do with our diet and what we need to do with fat. Okay. So we have the Institute of Medicine, the IOM, that says that 20 to 35% of total calories should be fat, and that's the acceptable micronutrient distribution range. The American Heart Association says less than 30%. The American Dietetic Association, the American College of Sports Medicine says between 20 to 25. So, a lot of different opinions. You know, if you go by the simple rules of increasing fiber, high fiber, and decreasing fat intake, that is probably going to be one of the healthiest diets you can do. So, off a 2,000 calorie diet, this is by the American Heart Association, is 66 grams of fat, which is 35%, which is 594 calories of fat for that 2,000 calories. So when and it's important to look at the food labels when you are buying your food and make sure that you need to know if it's a percentage or if you need to know if it's in grams. So it's important to read through food labels. And we actually have a whole exercise that we're going to do on food labels, which I'm sure you guys know how to do, but it'll be good. So the American Heart Association says that saturated fat, so now we have different kinds of fat. We have saturated, trans fat. And so we're supposed to have less than 7 to 10% of saturated fat in our diet. In trans fat, we're supposed to have less than 1%. And I think I'm going to go into trans fat here in a second, but I want to make sure I don't think you're actually, oh no, we're going to it's right here, okay, good. So this is just a table, and it just goes through different calorie intakes, and then you know, how many fat calories or grams of fat or grams of saturated fat, or it just goes through what's the recommendation for the different calorie levels for your diet. So like for me, I can have up to, well, based on exercise, about 3,500 calories per day. So this just gives you some general ideas of how you should organize your fats and how you should monitor them. And that's in the book. So lipids, we have triglycerides, which is an essential fat, which means that we ingest it, make up about 98% of fats that we intake. And that's oils and natural fats and nuts and all that. Okay. And then we have something non-essential, which is something that's made in our bodies. So when you hear non-essential for vitamins or non-essential for fat, I mean, it just means that we make it. And cholesterol is made in the liver. And then we have phospholipids, which is made from triglycerides, which is also a non-essential amino acid, or not amino acid, but fat. So then we have something called omega-3s and omega-6s. And we're going to go into, I'm going to show you what they look like and how the bonds are put together. So we're going to, in 2 slides, we'll go through that. So what does the triglyceride look like? It's basically glycerol with 3 fatty acids attached to it. So when the body breaks down the triglyceride, it normally separates the fatty acids and glycerol. So that happens in the cell. So let me go through this. So when we have triglycerides, a lot of times we'll get these results back from when we get blood work. So there's certain numbers associated with what our triglycerides should be in our bloodstream when we get this back. So I want you to probably write these down because these will be important normative values, and you might know this anyway. But definitely for nursing, you'll see these results in the charts. So this will be kind of important. So triglycerides are measured from blood panels in milligrams per deciliter. Okay, so that's when I talk about numbers, it's milligrams per deciliter. So less than 150 milligrams per deciliter of triglyceride is normal. Okay, less than 150 is normal. So borderline high is 150 to 199. So that means we're starting to get borderline high with triglycerides in the bloodstream because that's what it's measuring. And then anything above 200 is considered high. Okay? When you have high triglycerides, it's also associated with increased coronary heart problems and also increased plaque buildup in your arteries. The borderline is between 150, I should say 151 and 199. Okay, so now we get into types of fatty acids. So why do we hear this word saturated fatty acid? Interesting. So if we look at the slide here, we have these double bonds, double bonds, double bonds, double bonds, double bonds. And the double bond means that it's unsaturated, but there's no double bonds in the saturated. So that means all the carbon molecules have hydrogen attached to them. The carbons are saturated with hydrogen, hence saturated fat. Make sense? Okay. So then we have unsaturated fatty acid. So we have a double bond there, and it can't be saturated with hydrogen. So this is an unsaturated fatty acid. Okay. So now we've got this thing called trans fat, which is unsaturated. Okay. But the hydrogen, so the hydrogen is on the same side here, and then if we look at the trans fat, the hydrogen is located on the opposite side. So that's what makes the difference between a trans fat and a saturated fat, or an unsaturated fat. So unsaturated fat, the hydrogen's on the same side, and then the unsaturated fatty acid is on the same side. Unsaturated fatty acid, trans fat, is on the opposite side. So how do we get trans fats, and are they healthy? Are trans fats healthy for us? No, they are actually, in most countries, they're banned. And in this country, they're banned too. So trans fat is where we will inject hydrogen into an oil to solidify it, to make it so it's thick. And why would we do that? So we can spread it on things. So that's why the food producers do that. They inject hydrogen into fat to solidify it so we can use it for dietary use. And it is extremely unhealthy. So it's been banned. You'll still might see it in some products, like baking, like cookies and baked products like that, but not much because it's been banned in this country. So when I'm doing my chronometer, my trans fat always goes into the red. That means I'm getting trans fat from somewhere, but I can't find it anywhere on food labels or anything. So they don't have to put it on food labels if it's less than 0.05% trans fat. Tricky. So by the time I eat the food throughout the day, I actually then go above my trans fat that I'm supposed to have for the day. So there's ways even around that. Kayla?
So trans fat never occurs naturally, like in nature? Like a
No,
molecule
it's-
never form like that naturally?
It's man-made. It's a man-made substance. Okay, so then we have polyunsaturated, which means we have more poly, meaning more than one double bond. Monosaturated means we just have one double bond. Okay, so that's why the difference between mono and poly. Okay. Then there's the omega-3s. So the omega-3s, there's a 3 in this, so why? Why is there an omega-3 and omega-6? Omega-3s actually have 3 carbons from the end, 1, 2, 3, before the double bond. So that's where they get their omega-3. Okay? So from the end of the fatty acid, there's the 3 carbons. So those are all the differences between the different fats. I hope that made sense. So there's your chemistry for the day. Well, you might have more chemistry there, I don't know. I don't know what other classes you have, but there's definitely some chemistry. Okay, so these are just percentages, and the percentages are the numbers across the bottom. And these are the different oils and margins and the type of amount of fat they have and how much fat they have and what they're composed of. So you can see saturated fat, monosaturated, polyunsaturated, and the trans fat are all at the top. So if we look down at trans fatty acids, margarines, shortenings, they all have that trans fat in them, okay? And also, looks like butter at the top too. So those are the things when you're reading down your ingredient list, if you see something as trans fat, just know that is super bad. It's bad for you. A lot of chronic diseases are associated with increase in trans fat in the diet. Okay. Okay. So omega-6s, let me get on the right page here. Linoleic acid is what an omega-6 is. And it happens in vegetables and nuts and oils, seeds, nuts. And we're supposed to get 12 grams a day for females and 17 grams a day for males. Omega-3s are the linolenic acid. So we have linoleic acid and linolenic acid, and or otherwise known as omega-3 is lenny. And that is your flax seeds and canola and nuts, seeds, oils, and green leafy vegetables. Okay. So everyone hears about take that fish oil to get your omega-3s. Is that right? Everybody heard that before? So fish, when you look at fish, and when they do testing on fish happen to be one of the most toxic foods you can eat. And the reason it's so toxic is because where do a lot of companies dump their pollution? In the ocean. Okay? And there's a lot of countries that don't have a lot of regulations, so they can't do that. So, like for instance in the Great Lakes, PCB, mercury, that's really high in fish in the Great Lakes. So, and even, I think you've heard this, like women that are pregnant, they're only supposed to eat a limited amount of tuna fish, like per week. I don't know if you've heard this, but it's a thing, and it's about the mercury and it's about the toxins within the tuna fish, and of course we don't want it to get into the baby. So, I don't want to scare you away from eating all seafood, but it is fairly a toxic food. So now if we take the fish oil, and then we extract the omega-3s from fish oil from fish, there's a potential we could be getting toxins. So where does the fish get their omega-3s? Do you think they just produce them within their own body? They're not, because they are they are essential or non-essential? They are non-essential. No, they're essential, sorry, they're essential fatty acid for the fish. So where does the fish get them? What's that? Yes, exactly. It gets it from algae, mostly from algae in the water. So why would we eat fish oil to get our omega-3s when we can just get the algae and eat the algae instead? Does that make sense? Yeah, okay, that makes sense. So the same thing with B12. I mean, where do we get B12 from? Does anybody know? It's a hard question. We mostly get B12 from meat. Well, where does the animals get B12 from? What's that? Yeah, they get it from actually the dirt. So the bacteria within the dirt, they pick up that B12 from the dirt. So I don't think you guys should eat dirt, but anyway, you can supplement with B12, and they have supplements that you don't have to go through animals to get vitamins, okay? So the same thing with fish oil. So and actually, if you go into a store, if you go into a health food store, they'll have this product and you can buy it. So if you're lacking in omega-3s, when you do chronometer and notice that how much you're lacking in omega-3s, you can just go get that supplement from the health food store. And we're supposed to have 1.1 gram for females and 1.6 grams for males. In the standard American diet, which one is more prevalent, the omega-6s or the omega-3s? Omega-6 is very prevalent. And omega-6 has been linked to a lot more inflammation in the body, the cause of some inflammation.
Are you going to tell us when we're supposed to start tracking our stuff?
Oh, the chronometer?
Yeah.
Yeah, actually, I think there's there's an exercise, a homework exercise that is, I don't know, it's only like a 3 or 5 day thing, and that's coming up in March. But, I mean, I could always expand it if you wanted to, that's fine with me, so. But anyway, so yeah, it's coming up, I'll let you know,
Okay.
way in advance. Okay. So, I think that covers everything I want to cover there. Oh, here's trans fats right here, sorry. We kind of jumped ahead with trans fats. Okay. So defined is an unhealthy substance that is made through the chemical process of hydrogenation of oils. That's when they introduce hydrogen into the oils to solidify them. The hydrogenation solidifies liquid oils and increases their shelf life and the flavor stability of oils and foods that contain them. So trans fatty acids are found in vegetable shortening and in some margarines and crackers and cookies and snack foods. So trans fat acids are also found in abundance in deep fried foods. So it sounds a lot like the standard American diet right there. So it's known to raise the LDL level and lower HDL, and everyone knows that, well, not everybody, but the LDL levels are our good cholesterol, and our LDLs are bad cholesterol, our HDLs are good cholesterol. So we want high HDL and low LDL, but trans fats reverses that, okay? So we're supposed to have less than 1%, so less than 2 grams, but really we should probably have 0. So it is banned in many countries, including the United States. So that covers trans fats.
How much of one did you say that they can have in food without putting it on food?
Yeah, so I think it's less than 1% because they sneak it in like at 0.5 or 0.05, so they just sneak it in below what is that 1%. So that's how they kind of sneak it in. So what are fat substitutes? So these are kind of weird, I think. So fat substitute are designed to produce the taste and texture of fat, but without the calories. May be manufactured from carbohydrates and proteins and fats, and may contain 0 to 5 calories per grams. So like Ulstra is one that's made from fat and carbohydrates using a long chain, and this long chain is undigestible. We're going to cover that in a minute. So this is an example of Olestra, and this is the chemical makeup. So here we have a triglyceride, and this is what olestra is made up of. And the body has no idea what this is, and it can't break it down. So it's pushed through the digestive tract, and it's just eliminated. So the body has no recognition of what it is and how to break it down.
Do fat substitutes, like, do they provide energy and stuff for the body, or are they just for, like, the taste and stuff?
Yeah, most of them are for taste. We have to kind of pick it apart one by one, though. I'm just giving you an example of a couple of them. They don't use a lot of fat substitutes, but the ones they do use are typically the only reason they use a fat substitute is to taste and also decrease calories. So, and normally, like in this case, it's normally undigestible. And a lot of times it will cause upset stomach and diarrhea, things like that, because the body just doesn't know what to do with it. So, does that answer your question? Okay. So a chylomicron is a type of lipoprotein and is formed by free fatty acid and triglycerides, and cholesterol is transported to blood via the lymph. So this is a medium chain triglyceride, and with 2 or 3 fatty acids. Let's see, trials. Okay, let's go to the next one because I'll show you an example of what one looks like. So we can see the green dots here, the triglycerides that are located in here. We have proteins, we have phospholipids, free cholesterols, and this is the cholesterol bound up by fatty acid and through the triglycerides. So this is called a chylomicron. Okay. So let's go to the next slide here. So in particular, this goes through the digestive system and is carried out by the lymphatic system out to the body. So let's talk through everything this is figure 5.6 in your book. So in the mouth, there's very minor digestion of fat. And then number 2, pancreas, fat ingest mainly into monoglycerides and free fatty acids by lipase enzyme released from the pancreas. So number 3, in the liver, bile made by the liver aids fat digestion and absorption. Has anyone ever noticed someone has gallbladder problems and had the gallstones and the gallbladder doesn't work good? And what do they typically say? When I eat this kind of food, it kind of upsets my gut. What's that?
Greasy food?
Yes, greasy food, fatty food, because this is what we're talking about here. The bile is made by the liver, and it goes through and aids digestion and absorption, but the bile goes through the gallbladder. Okay, so the gallbladder releases it. So when you have gallbladder problems, you normally have problems with digestion. Number 4, fat is absorbed fat is absorbed and mostly made into chylomicrons and transferred into the lymph system. Okay, so this happens in the small intestines. So this is where everything is combined together now. So the body combines the triglycerides and the proteins and the phospholipids and the free cholesterol and combines into this little capsule. Oops, let me go back. So less than 5% of fat normally is excreted in feces. So that kind of takes you a trip through the digestive system with fats. Okay. Too far. So then we have something called, and this was talked about in the video too. This is excreted by the liver. Is a very low density lipoprotein, and it's produced in the liver. Okay. And what Dr. Greger was talking about, when you have a fatty liver, so let's talk about fatty liver for a second. Has anyone ever heard of fatty liver syndrome? Yep. And what causes fatty liver syndrome, besides what Dr. Greger just talked about? Is there another cause of it? What's that? It does, yeah. So my wife we were trying to get some health insurance, not health insurance, but life insurance on her, and they did a blood lipid profile on her, and they found out she has a fatty liver. So they thought she was a drinker, And so they denied insurance coverage because she had a fatty liver. She doesn't have a fatty liver due to alcohol, it's due to standard American diet. But I thought that was kind of interesting. They denied health cover insurance because she has a fatty liver. But that fatty liver is a precursor to type 2 diabetes. So what's happened to her? Well, actually through the course of her chemotherapy, the chemotherapy stressed the liver, and now she has kind of stress-induced diabetes. So the fatty liver was the precursor, and the chemotherapy then stressed the system and then had pushed her into diabetes. So that fatty liver I thought was a great example of a precursor to diabetes. So let's see, the VDL transports triglycerides from the liver to the tissue. Then we have something called low density lipoproteins, which are also produced in the liver and are made of high cholesterol and low protein, and transport cholesterol from the liver to the tissues, similar to the lipoprotein A. So LDL and VDL are similar, except we have more triglycerides in the VDL than we do the LDL. They're both lousy. And one of the things about the LDL that I thought is interesting, the LDL, on the external surface of the LDL has these little jagged edges, okay? So when it's being transported in the blood, a lot of times it'll land and hit the arterial walls, and it'll create like a little bit of an injury. And sometimes it'll attach to that area. So then what happens is there's damage to the epithelial cells, and then an inflammation response starts. And that whole inflammation response that happens after that is the start of the plaque buildup. So these little LDL guys have these little nasty little hooks on them, and they'll go and they'll plant themselves into the wall of the arteries, which starts this whole process. But LDL is a high density lipoprotein, and it's made of low cholesterol, high protein, and it takes cholesterol from tissue to liver to dismantle. So these LDLs are traveling through the bloodstream too, and if they're high, a lot of times what they'll do is they'll take the LDLs and they'll transport them back to the liver. Okay, so the HDLs actually go into the bloodstream and pull LDLs out of the system. So that's why it's important to have high HDL and low LDL. Make sense? Okay. So we're going back to the chylomicron again. Okay. So dietary fats, they enter into the small intestines, and they're broken down into free fatty acids, to glycerol, to cholesterol, and to phospholipids. So that's what happens in the small intestines. And then in the intestinal wall, they get put all back together again into something called the chylomicron. Okay? That's that little ball I showed you a second ago. Okay? So then the chylomicron then either goes in a couple different places. It goes to the muscle, or it goes to the adipose cells, and then it's stored as a triglyceride or used for energy. Or then it gets kicked, or it goes back into the bloodstream. And then the liver either breaks it down and recombines it in a lot of different ways, because the liver can do this. The liver can break substances down and then put it back together. It just depends on what the body's needs are, and the hormones, as the hormones are kind of dictating to the liver what needs to be done, different hormones. So from there, it can be, the chylomicron can then go back into the bloodstream and back into muscle and used for energy or cellular structure. So it goes in two different directions. It's either going to go directly into the bloodstream, out to the muscle or adipose, or it's going to go into the liver, and it's going to get put back together with whatever configuration the body needs. So those are the two. Those are the two ways, two areas they go, to the chylomicron go. So we've seen this one before. The important thing here is that we have, this is the how fat can make carbohydrate or make energy. So the glycerol can combine with the pyruvate, acetylcholine, and then it can go into the Krebs cycle. So that's one way it can happen. The glycerol can actually go into pyruvate and then go into make amino acids out of it. So the fat can help with amino acids and protein synthesis. It can also help with carbohydrate synthesis. But that process is very, from the glycerol doing that to making the amino acid is fairly common. But the fatty acid then combining with acetylcholine to make amino acid is very rare. So those are the different ways proteins can be converted to carbohydrates or protein. So, fat produces energy, but only with the aerobic process because it needs oxygen. Fat provides about 60% of energy at rest. So then we have something called ketones. They are the byproduct of the breakdown of fatty acids. And they are active when when our carbohydrates are low. So when our carbohydrates are low, when the glycogen in our muscles and in the liver are depleted, then our body then starts to break down fat, and then that starts that produces ketones, which then can go into ketosis, which we'll be talking about in a little bit. So examples of how our body will start using ketones and producing ketones are when we're fasting. And fasting is something as simple as sleeping for 8 hours. That's going to happen. High-fat diets, which is like the ketogenic diet, and also diabetes. So what we have here is just the different storage that fat has. So an average adult male has enough fat storage as energy to run 3 marathons. Most fat is stored in the adipose cell, about up to 2,800 calories. 100 fat calories are stored in the muscle cells. And then about 20, no, that's right, yeah. But you can't burn fat or fuel without fragments of carbohydrate, or you will end up in ketosis. Okay, so even when we're burning fat, we have to have a little bit of carbohydrate in order to make the process happen. So in ketosis, the easy way to explain it is basically ketones are produced when you eat very few carbs, and that's what we just talked about. Only moderate amounts of protein. Under these circumstances, fat is converted in the liver to ketones, then enter the bloodstream. Then they are used as fuels by cells in the body, just like glucose. They can even be used in the brain. So ketosis, we're going to go into a little bit more on Wednesday on ketosis, because we're going to go into the ketogenic diet, and we'll explain that. So that is it for today, and I will see you guys on Wednesday. And we're going to get a little snow on Tuesday, so it sounds like we got a little snowstorm coming in, so have fun in the snow. Is anybody on for Devo for Wednesday? Okay, good.